In materials chemistry, characterization plays an important role as it provides essential information on the structure, composition, and chemical functionality of materials. Polymers, in particular, exhibit a wide range of physical and chemical properties depending on their molecular structure and origin. These properties influence their performance in various applications, including textiles, packaging, insulation, and biomedical products. Therefore, understanding the differences between natural polymers and synthetic polymers through systematic characterization is fundamental for both academic research and industrial development. In this practical, two polymers with significantly different nature and properties were selected. The first is cotton, which is a natural polymer. Second is polystyrene, which is a synthetic polymer. Other materials included ethanol and platinum sputtering target. To effectively compare these two polymers, several analytical techniques were employed. First is scanning electron microscopy coupled with energy dispersive X-ray spectroscopy or SEM-EDX. The second was Fourier transform infrared spectroscopy or FTIR. Cotton fibers exhibited a classic fibrous and ribbon-like morphology at all magnifications. The sample appeared as a complex yarn of tangled and overlapping strands at lower power of X30, as shown in Figure 1a. Higher magnification of X200 in Figure 1b resolved individual fibers as long, flattened tubes. In contrast, polystyrene sample displayed a completely different non-fibrous architecture best described as cellular or honeycomb-like. As seen in Figure 2a, the sample appeared as large and fractured chunks in X60 magnification, whereas higher magnification of X200 in Figure 2b clearly determines internal matrix as a rigid and repeating network of closed cells or air pockets separated by very thin walls. Cotton had a composition of 61.64% carbon and 38.36% oxygen by mass. The high oxygen content confirms the presence of the carbohydrate-based polysaccharide backbone of cellulose, identifying cotton as a linear and natural polymer evolved for moisture absorption and tensile durability. Polystyrene was conclusively identified as a pure synthetic aromatic hydrocarbon, revealing a composition of 100% carbon by mass with no detectable oxygen. This chemical simplicity and the absence of biological markers confirms its identity as a synthetic bulk polymer, specifically expanded polyestyrene, which is designed for high thermal resistance and low density. cotton sample displayed characteristic absorption bands of a carbohydrate-based structure, confirming its primary composition as cellulose. Polystyrene spectrum presented a fingerprint definitive of a synthetic aromatic hydrocarbon, lacking oxygen-containing functional groups. In conclusion, the characterization and comparison of cotton and polystyrene using SEM and FTIR analysis was successfully achieved. SEM analysis effectively revealed the surface morphology and microstructural differences between the two materials, especially when coupled with EDX. FTIR successfully identified and differentiated the two polymers based on functional groups.